Yeah, guys. So welcome back to the chemistry class. Today we are talking on redox reactions of carbonyl compounds. This already the redox reactions I have taught: failing solutions, Benedict solution, and intolerance reagent. Then let me also introduce these all things done here. Iodoform test also I did. I think this is the last slide. Yeah. So then the other topic is nucleophilic addition reactions. This is the topic of discussion for today. Learning objective: understand the reactions of carbonyl compounds with HCN in presence of KCN as a nucleophilic addition reaction using curly arrows, relative lone pairs, dipoles, and evidence of optical activity to show the mechanism. Okay, and the second equation is second reaction is very important. That is 2,4. The reaction of carbonyl compounds with 2,4-dinitrophenyl hydrazine. That also we can call as 2,4-DNPH as a qualitative test for the presence of this group. So generally, the presence of carbonyl groups in a given compound, if you just add 2,4-dinitrophenyl hydrazine. I'll show the structure of this. You need not worry. It looks just on phenyl, you have an hydrogen group. It's so simple. Don't worry. So 2,4-dinitrophenyl hydrazine. When you add to a compound, if it has a so-called any carbonyl compounds in them, then it turns here. It produces yellow to orange PPT. I have all these experiments. You need not worry. But in the learning objective, first we focus on reaction of HCN with carbonyl compounds and its mechanism. Then if time permits, we also discuss on this. Okay, so let me not waste time on this. Right. So reactions with hydrogen cyanide. So this is your carbonyl. Aisha, this is aldehyde or a ketone? Hello, don't waste my time, guys. Whether this is an
Yes,
aldehyde
sir.
or a ketone.
Ketone.
Are you sure? Check for the name, Aisha. Are you
Uh,
propanol? The name is ending with AL. So it's an
oh,
aldehyde.
yeah, aldehyde.
So it's a propanol. So aldehyde when reacts with HCN, it is a nucleophilic addition. See, nothing can be like removed. So this HCN is directly added over on this propanol or on this carbonyl compound. Am I clear? So how it is added, you will understand in the mechanism. It is so simple. By nature, by default, are you getting me? By default, this carbonyl compound has little polarity. There's a polarity difference between these. So because of this polarity difference between this carbon and oxygen attached over here, electrons can little move over this oxygen. Am I clear? See the mechanism I'll show. So when electrons move on to this oxygen, this carbon develops a partial positive charge. So this carbon will act as a carbon carbocation, and this has now a negative charge. So now this carbocation will be attacked by a nucleophile. So what do you mean by nucleophile, Aisha? What is a nucleophile?
Nucleophile is
Nucleus loving. Okay,
yeah,
which loves or which likes nucleus. So what is the charge of the nucleus? I mean, nucleus will have usually which what kind of charge? Positive or negative?
positive, positive.
Positive. So now this nucleophile, which there is a positive center on this carbonyl compound by nature because of the polarity difference of this carbon and this oxygen. So now a nucleophile will attack here. Am I clear? Hence, our topic for today is nucleophilic addition reactions. Am I clear? I hope I'm clear with this. So our topic is addition of nucleophiles or nucleophilic addition reactions on carbonyl compounds. I hope I am clear. So your nucleophile from this HCN, generally HCN initially, which splits into H plus and Cn minus. Okay. So now you have H plus and Cn minus. My question is, Usman, which is the nucleophile in both of these? You know, H plus ion and Cn minus ion, a cyanide ion. Which is the nucleophile in this?
Sir, H plus.
H plus will be attracted.
No,
Then
Cn minus.
Cn minus. So Cn minus will attack here. So that see, you can see nothing else. You see just the Cn. There is no change on this carbon or on this carbon. Only this a carbon or a carbonyl carbon only the attachment takes place. See the Cn being there is a positive charge. So this negatively charged Cn will attack, which acts as a nucleophile, which attacks on this carbon. Now this hydrogen. Now actually we take 2 moles in fact, but here only I'll explain. So now this oxygen has a negative charge, but this hydrogen do not have any electrons with. So this hydrogen will go over here and add it on this oxygen. Hence your compound is, see, nothing else. Only just in a simple way, blindly you can just remember. Think of only a carbonyl carbon in this carbonyl compounds, or think of a carbon to which oxygen is attached. So don't disturb any other carbons. Okay, I'm not disturbing any of this. Even I'm not disturbing this hydrogen too. Only on this carbon and on this oxygen there are some changes. Am I clear? So please understand the logic here. Nothing, you need not remember everything. See, an acetone or an aldehyde or a ketone is given, or if not a carbonyl compound is given, right? If it is HCN, the CN part will attack this carbon. Cn minus will act as a nucleophile, then the hydrogen from other mole or other molecule will attack on this oxygen, because this oxygen partially develops a negative charge. Okay, hence now the Cn you add over here, am I clear? And H over here, then you get this the product. Okay, examine the addition reactions involved by hydrogen atom. So can you read this, Aisha?
Yes, sir.
Aisha, if not Gaby, yeah, please Aisha, fast.
Examine, right? Yeah.
Yeah.
The
Exam.
addition reactions involve a hydrogen atom attaching to the oxygen atom of carbonyl group and a cyanide group attaching to carbon atom of carbonyl group.
That's what I was explaining since this time, since long time. Yes or no?
Yes,
Any
sir.
questions? Gaby, Usman, Nastia, Aisha.
No,
Only four
sir.
of you. Somebody join. Yes, please.
Sir, Nadali joined.
Nadali, any questions? Did you, are you able to like
Morning, sir.
analyze this equation?
Yeah, yeah, I
It's
got
so
it.
simple.
That's
You just think of the, so I'll show you the mechanism there also. There you get more clarity. Don't worry. Okay, no worries. So may I move to the next slide?
Yes, sir.
So, right. So first, let us see how this. See, this is a new name. I'll like a new name has come. This we did not discuss before. So when CN group is present in a hydrocarbon, then your alcohol group will become a subgroup. So then you have to give the name for that as hydroxy. Then this CN, if CN is present, you have to end up the name of the compound with the nitrile. Okay, so this is very important. You can check for the rules. So naming product of nucleophilic addition reactions with hydrogen cyanide rules. OH group should be shown as a prefix, reading, prefix, and CN should be shown as suffix. Means the name of the compound should end with CN, but CN is, if CN group is present in a hydrocarbon, it is a nitrile. If OH group is present as, I mean, this will become so what is given? This will become prefix, but prefix you cannot say alcohol over there. So when alcohol group is acting as a prefix, so then the name is replaced, OL replaced by hydroxy. So if you just look into this compound here, if you write this is a structural formula. If you write a displayed formula, you can understand this compound can be written as like, so you have to always start numbering from here. So this is this carbon also we count 1, Can I name? This is 2, this is 3, and this is 4. KB, am I clear? So this is how you're naming. Now, on the second carbon, you have, if you write this displayed formula for this compound, you will understand that on the second carbon, OH group is present. Hence, 2. If OH is present, hydroxy, you need not give any gap. So then the total length of the chain is 4. Then it has CN group, so then nitrile. So 2 hydroxy butane nitrile. Any questions? 2 hydroxy butane nitrile. So these two simple rules you just keep in mind, then it's easy for you to understand. So this is now. Similarly, now you need to count where is the CN? CN is over here. But first, what happens? You have to check for the position of OH. So OH is also present. This is like, can we write structural formula for this or displayed formula? Yeah, name I gave. So in order to avoid the further confusion, first write down the structure, sorry, displayed formula of the compound, like CH3. On this carbon, you have, what are the groups present on this carbon? Aisha, can you identify?
Yes, sir.
What are the groups present on the second carbon? Are there any hydrogens?
Six,
No.
seven.
Sir, OH group is present.
Yeah, OH, because OH and CN are kept in brackets, so you have one CN over here and OH. So the job, I mean, again the rule is same. So there is uh, alcoholic group means which acts as a prefix. So 2 hydroxy and 2 methyl butane, no, 2 hydroxy, 2 methyl, what is good? 2 methyl butane nitrile. So total length of the carbon, again you check 1, 2. So what we do is again 1, 2, 3, 4. So this methyl group will become another substituent. So not the cyanide. So all the time when you have cyanide group, the name ends with the nitrile. So you're not giving any numbering to the cyanide. So carbon 1, 2. So on the second carbon, now total, there is a methyl group, there is hydroxy, I mean alcohol group, there is CN. But the name of the compound ends with CN only. So we are not giving any number for this. So hence 2 hydroxy, 2 methyl, then total length of the chain you have to think 1, 2, 3, 4. Okay. So then 2 methyl butane nitrile. Am I clear? So this is how we need to name this products of nucleophilic addition reactions of carbon. I hope I am clear. So now let's go
Yes.
move with the mechanism.
Yes, sir.
Okay. So nucleophilic addition mechanism, which has only 2 steps here. Such a simple, ever simple mechanism. I've already explained. Initially, what happens? This is your carbonyl compound. Can you see here, Usman? Guys,
Yes,
Nastia,
sir.
Usman,
Yes.
Aditi, Sarah, I can see.
Yes, sir. We can't hear
So
Yes.
you.
now, initially, just leave of this. Don't think of this at all. So initially, when compared with this carbon and oxygen is more electronegative atom. So because of this, its electronegativity, which pulls this loosely bonded pi electrons towards it. So because of that, now this carbon has only 3 bonds, so it will now this carbon will form as a carbocation. The step 1. So meanwhile, this cyanide, hydrogen cyanide will dissociate into H plus and Cn minus. Now this has a lone pair of electron. So now carbon has its deficiency of electron. So this Cn will attack by giving this pair of electron. Or here it's forming like a coordinate covalent bond, I can say. Okay. As this pair of electrons moved slightly towards this side, obviously this oxygen has a negative charge. So in order to attack this negative charge in the step 2, this hydrogen, am I clear? So this hydrogen will come and attack over here and share this minus charge, means a pair of electrons. Share this pair of electron and happily it stays like this hydroxy cyanide group. This is just such a simple mechanism. Any questions on this mechanism? Very important. So
No, sir.
nucleophilic addition
No.
reaction mechanisms. Am I clear with this?
Yes, sir.
Oh, thank you. So I hope we are doing great. I feel like, so please make a note of this today only. If you do it tomorrow, you will not understand. But I'm not getting any notes except from only the Gaby sending the work. Usman writing long notes, I think. Okay. Then, but how do we know this mechanism has taken place? Now, before that, let me just give you, or let me ask a few questions. What would be the shape of this carbonyl group? I mean, geometry of this carbonyl, which is planar or tetrahedral or trigonal? What do you think of this?
Sir, this looks like trigonal.
No. So all this, when there are no lone pair of electrons on this, so it's a planar trigonal. Planar trigonal. So means it's a plane. So now what happens is, two things I need to confirm. Now this carbocation is plane. It is in the plane. So when something is on the plane, an attacking group can attack from above the plane and from below the plane. Can you agree with this?
I don't know, sir.
No. See, if you have a paper, a plane like this, and some object is here exactly in the paper. Okay. Hello. You have just a
Yes,
plane, a
sir.
paper you take from your book. So now, in order to attack on this, a group can come from above the plane and below the plane. Yes or no? At least can you
Yes, sir.
understand that? Make this analysis. This is just common sense.
Yes.
Okay, you can hear something. A bird is exactly sitting here. Yeah, someone is flying from. Someone is in the aeroplane and someone is at the down, and this is a y related way. So you can shoot the bird from this side or you can from this side. Anyway, is possibility. Yes,
Yes,
sir.
sir.
So same way, now a nucleophile can attack this group either from above the plane or below the plane. Okay. See the type of the compound found will be same, but it results in the formation of enantiomers. Okay, which rotate the plane polarized light in different angle. If one is dextrorotatory, other will be levorotatory. Okay, so that can be
Okay.
understood here. That is an evidence. In fact, optical activity of the product is an evidence to prove that this is the mechanism or this mechanism involved in this nucleophilic addition reaction. So that is the story here. Now you understand. Nadali, can you read it, please?
Using
Nadali,
optical activity as an evidence. Sir,
little
can you not
higher,
hear me?
higher volumes. It's not audible. Yeah.
Okay. Um, Using optical activity as an evidence, the knowledge consideration of optical activity can be used as evidence for this mechanism. The two atom or group join to C double bond double bond oxygen is planar, which means that in step 1 there is an equal
Chance of.
cyanide ion attacking from each side of plane. So through the product has asymmetric carbon, there are equal amounts of both dextrorotatory and levorotatory and shimers
Enantiomers
formed,
formed.
giving a product mixture with no optical activity.
Yes, sir. So what we do is we just add some cyanide in presence of KCN to a carbonyl compound. Am I clear? You get some product, no issues. So we are testing for we are testing the optical activity for the product. Suppose if the optical activity seems to be zero, So our mechanism is confirmed or our mechanism is correct. You can't see it this way, right? Attacking simply it is all imaginary concepts. This is what happened. So out of the results, we'll make a confirmation. Am I clear with this now? Gabriel, Nastia, Usman and Aisha. Am I clear with my concept? So the formation of a compound with no optical activity proves that the mechanism of addition of HCN onto carbonyl compound might have taken in this way. Any questions? Hello?
No, sir.
See, my overall idea is this is now a carbonyl, this carbon is planar or these two molecules on the same plane. Now the CN can come from this side or from this side, so that two enantiomers, which are otherwise called as optical isomers, are possible. Am I clear? So that products also I showed, you need not worry. I hope I'm clear with the evidence, optical activity evidence. See here, let me confirm. See, so the product has asymmetric carbon, means a carbon with four different groups. Though you have carbon there, but there are equal chances of both dextrorotatory and levorotatory enhances. Dextrorotatory, which rotates the plane polarized light in clockwise direction, and levorotatory, which rotates the light in anti-clockwise direction. As both of them are enantiomers, they rotate the light to the same extent but of the same angle. So optical activity of both of them are cancelled by each other. So the compounds do not have any optical activity. Am I clear?
Yes, sir.
So this is
Yes,
how we
sir.
need to understand the evidence for this mechanism. Okay, so here ethanol and HCN, this is what I was explaining. For example, now this CN from above the plane, if CN comes from the above the plane, this is your product, and if CN attacks from the below the plane, this is your product. Okay, so this seems here above the plane and one is below the plane, then this indicates now there is a change of hydroxyl group. Now these both are your enantiomers. Enantiomers are otherwise called as optical isomers, which rotate plane polarized light in two different directions. One is clockwise and other is anti-clockwise. Am I clear? So because
Yes,
of
sir.
the mixture of the, your product has mixture of both of these in equal or equimolar concentrations. Hence the optical activity of the product is seems to be zero or ceases to zero or can finally neutralized to zero or nullified to zero. Anything you can use. Am I clear?
Yes,
Right.
sir.
Next, reaction with 2,4-dinitrophenyl hydrazine. Okay, before that I'll show you the structure of 2,4-dinitrophenyl hydrazine. So phenyl group, it is just you need to write a benzene ring. Are you aware of benzene ring? This one. This is your benzene ring. Sorry. This benzene ring. Then 2,4-dinitro. Here, if you have an hydrogen group, here will be one nitrogen. Nitrile group, that is dinitro, NO2 we just call, not nitrile. Dinitrogen oxide. Here you have another. I'll show the structure anyhow, but this is how we need to remember. Okay. Now on this, you have a cyanide, I mean a hydrazine group. So what is this hydrazine? You can check here, then we'll come back. So this is your hydrogen part. This whole thing. Okay. Let me, if you wish, like let me give this hydrogen part here only. So now at this point, now you have a nitrogen. How many bonds a nitrogen can form?
Sir, 4.
3. Nitrogen will have lone pair of electron all the time. Okay, hydrazine, and here NH2, this is your amine group. Am I clear now? So
Yes.
it is so simple to understand the product. Okay, you need not remember everything also. So what we do is this part is not disturbed at all. This nitrogen part. Only these two hydrogens combined with the oxygen of a carbonyl group, maybe aldehyde or ketone, then that is that goes as water, goes out as water, and remaining compound is formed. But before that, you can see here the differentiation test. Simple aldehydes and ketones give a yellow precipitate. Aromatic aldehydes means if you have, rather than having like propanone, butanone, aromatic means on benzene ring, there should be a carbonyl group like benzaldehyde. Okay, that when I deal with organic like aromatic compounds, I'll give more details. So, but if our aromatic compound, aromatic aldehydes and ketones gives a thick orange precipitate. Okay, this is an identification test for the presence of carbonyl functional group in a given compound. Okay, once the school reopens, we may do a test on this. Need not worry. Okay, 24-DNPH, short form 24-DNPH. Okay, so here now we check. So you are not worried to change anything except which is written in this red color. Okay, mechanism you need not, but in order to understand, remember the products formed, just remove this water here. Usman, can you see this?
Yes, sir.
Just get rid of this water. Now water has come out. So now as this oxygen has lost from here, okay, minimum nitrogen should have 3 bonds with it. So this whole group without any disturbance makes 2 bonds with this nitrogen. That's what happened. This nitrogen over here is not disturbed at all. This from this nitrogen, from this amine group, I can say hydrogens are removed, and from carbonyl group oxygen is, so that both get it's get rid of as, I mean it lasts as water. Now this same way, this whole group, whatever you have, this whole group will attack on this or will attach to this nitrogen, and here you can see that. Any other changes? No other changes are happening. This is NO2, NO2. You may get a question why it is 2,4-dinitrophenyl hydrazine. This whole group is called hydrazine, which we consider as a functional group in this, or a major group. So from here we should start numbering the. Gaby, are you getting? So this is one. Usman, now this is your second carbon, this is your third carbon, and this is the fourth carbon. Am I clear, Usman?
Yes, sir. Yes.
So because of this, now you can understand the name. On the second carbon you have dinitrogen oxide, and on the fourth carbon you have another dinitrogen oxide, and then this ring we consider it as phenyl. Okay, phenyl ring when it has some substituent. If not, we call as benzene ring. So now 2,4 dinitrophenyl hydrazine. This is phenyl, 2 NO2 groups, then this is hydrazine. So 2,4 dinitrophenyl hydrazine and propanal. Now this we can call derivative. Okay.
Okay, sir.
So that's simple to understand. So I hope I'm clear till here. One more slide to do, then after that you can leave my class, no issues. Any questions, Gaby? So you need not understand the mechanism. You just try to remember the product formed. But to remember how the product formed or what is the product formed, it's quite easy. Just if you have little idea what is happening over here. Nothing new. It's not like rocket science or Latin and Greek. So simply you remove this water, which is okay. And when you remove this water, this carbon which makes a double bond with this nitrogen. That's what happening here. No other thing. So we give this the name as 2,4 dinitrophenyl hydrazone. Okay, hydrazone derivative of propanol. Okay, it is a derivative of propanol. So these are generally, we got the new word like derivatives. Okay, there will be main functional group, but to that some other substituents are attached. So no other change except this. So this we can call as derivative. Hope I am clear. And what is the purpose of this test? So I told you This is your yellow to orange precipitate, please. So if at all there is a car, see 2,4-dinitrophenyl hydrazine or 2,4 DNPH is a reagent. When you add this reagent, here I told you, here I've explained, add few drops of 2,4-DNPH to a solution of the compound. If there are simple aldehydes in your sample solution or in your sample, you get a yellow precipitate. If there are all aromatic aldehydes, you get orange precipitate. Anything on this identification test? Any questions, please? Aisha, Usman, Gaby, Nadali, and Asliya.
Yes, sir.
No, sir.
Hope I am clear with this. Okay.
Yes, sir.
See, always I request you, I consider you guys all the time. See, when there is a chemistry lesson, you need to finish the notes on the same day. If you write the notes on some other day after a week, you don't understand. That's the problem with the chemistry. See, now this will retain for 1 or 2 hours. If you write, that will strengthen your memory. Okay, if you write after a month, okay, I'm not saying you're skipping the work. If you write today itself, you get some ideas. While writing, you'll get some ideas. Am I clear?
Yes,
Suppose,
sir.
Yes, sir.
please do make a note. If you wish, I'll share this slide again. Okay, I hope I am clear with this. So write the product. Suppose what I do is, this is your aldehyde, right? So you need not worry, just replace this. Suppose this 2,4 2,4 DNPH is same. What I do is, you can take this as a homework. You add some propanone here. You add some propanone. I show what is the formula for propanone. I mean structural formula or displayed formula. Propanone is an aldehyde or a ketone? Nadali? Are you guys there? Propanone is an aldehyde or a ketone?
Aldehyde.
So,
Why aldehyde, Usman? ONE. The name is ending with ONE, so
Oh,
it is a
sorry.
ketone.
It's
Please remember, if the name ends with
sir.
A,
You are asking propanol.
propanone, yeah.
oh,
It's,
sir, I thought
No.
propanol.
here I wrote here, propanone. Okay, so if the name ends with Al, it is an aldehyde. If the name of a compound ends with One, it is a ketone.
Ketone. Sir, I also know this.
Sir,
Okay.
But I
it is
heard you as propanol.
Okay, please. Yeah, somebody is asking a question. Yes,
no,
please.
sir. Structure formula. It's CH3 bracket 2CO.
Yes. CS3
Bracket 2.
CO. So if I write the structural formula, it's CS3CO CS3.
Yes, sir.
Dimethyl ketone we call. Or also we also give propanone. Okay. And if it is some other thing like this also, like propanone, and how many are there? Acetone also, do we call this is a acetone too? This is used as a like nail polish remover, guys.
Yes, sir.
Fine. So this is all about nucleophilic addition reactions. You guys may, okay, last slide you can check. Then what is the importance of this now? So this test also is useful in order to differentiate carbonyl compounds or some of the organic compounds which have same boiling points. Here I got the last slide. The melting temperature of derivatives. See, pentanol, pentane 2 one, then pentane 3 one. This all has same boiling temperature. So if this is the case, it is too difficult for me to identify based on boiling temperature. Am I clear?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
So in order to avoid this, what I do is I'll just add see, I have three different samples, but we guys are not clear which is pentanol, which is pentane 2-ol, and which is pentane 3-1. Okay. So what we do is just you add 2,4 DNPH, 2,4 DNPH to all these different samples, then collect the derivative, then check for the melting point. If something melts at, so melting temperature, melts at 104 degrees centigrade, which see that initial compound is your pentanol. If it melts at 144, it is pentane 2-1. If it melts at 156, this is how the derivatives are useful in order to distinguish between pentanol, pentane 2-1, and pentane 3-1. Okay. So why we are like stressing, I mean, we are discussing so much on this. Actually, based on boiling points, these melting points, they got a lot of industrial importance in synthesis, like in pharmaceutical industries. Okay. See, you can
Yes.
see that the original carbonyl compound can now be identified by matching experimental melting temperature of its derivative to a value in the table. Okay. So thank you so much for joining. I have other class to go. So hope you understood to the
Yes.
better extent.
Yes, sir.
Please do write, at least you leave off when suppose if your notes is incomplete, no worries. Just write today's topic somewhere so that it will give you a little like idea when you are writing on your own. Thank you. You may leave now.
Thank you, sir.
Welcome, Aksha.
Bye, sir.
Sir, one question.
Yes, please.
Sir, which unit is this? Unit 5 or 4?
This unit is 550. Okay, I'll share you the. Give me a second. Topic 15. Okay, unit 5 dinitrogen. No, give me a second. Unit 4, dear. Unit 4. Yeah.
Okay, sir. For
Unit 4,
test unit,
topic 15.
sir, for test unit 4 will come, right?
Yeah, only two topics in this. So what did I finish
Okay,
in
sir.
this? One is acid base equilibria, the Bronsted law. Okay, only topic 14 and 15 you will get, nothing else. Okay,
Okay, sir. Perfecto.
thank you.
Sir,
Yes, sir.
also share the
Thank.
PPT.
Yeah, I'll share.
Thank
Thank
you.
you, sir. Bye.
Bye.
Bye.